Monte Carlo Markov chain, maybe your error bar is going to better, and maybe your result a little change. It is just a suggestion for you because of your number of your data.
Things will degrade a bit if, yeah, the more realistic you get. I agree.
Okay.
I agree.
Okay, Roger, I'm.
Yeah, go ahead.
Yes. Okay, do you see my slide?
That looks good to me, Attila.
Okay. Hello, everyone. I'm glad to be here to have a presentation. I'm from Iran now, and here is about 3 a.m. Okay, thank you to IOTA for this opportunity. My presentation title is Study of Pluto's Atmosphere based on 2020 Stellar Occultation Light Cave Results. It was an interesting event, and at first we decided just to observe it, but according to a good study on the last papers about this, and also predictions on this event, and having a good team, surely we started for observation process and then light curve analysis of this event. Next slide. Okay, what we did, we observed a stellar occultation by Pluto on 6 June 2020. This observational data was used to obtain the atmospheric pressure of Pluto. Furthermore, the results about the obtained parameters are presented in this study, and we wrote an article about that. We wrote all of result as an article, and it is in the processing in a journal, revised. Okay, it is important of two steps during this project. First, about challenging in observation, and second one is about writing Python code for analyzing because nothing in access. Okay, about predictions, the occultation happened with Pluto and the stars that you can see via the R2 ID of it on this slide, and we got our prediction information from Lucky Star project website and also the IOTA website. We also had a study on other project about Pluto occultation for observation section, especially. In this step, we had an advice team of astronomical photographers in Iran to know how we had a good photometry. The observation was made with equipment of the private ASAL observatory in the north of Karaj city in Iran. To improve the observing position, the place was identified at a height not far from the observatory, and the observatory equipment was transferred there. It is about 5 kilometers far from the observatory, and the observation place was 2,220 meters above the main sea level, so it is very high. The picture is about 3 days ago, July 15. And there is dust storm on the horizon. It was a climb with I climbed there with my wife for taking this picture, and also Next slide for the picture. This is an access road to reach the top of this mountain. So the equipment transferred there by car by this road. Okay, we have two telescopes. The main telescope is 24 inches Schmidt-Cassegrain. The second one is for 14-inch Schmidt-Cassegrain Celestron telescope installed on the main telescope. Both telescopes are on the Poro robotic mount. It's very good robotic mount. And as I said, we had a photometry for our method, and the filter was clear, not without filter. And two CCD SPIG was on the both telescopes. The average temperature of the CCD during the observation was -25 centigrade. The exposure time was about 4 seconds. The exposure time to cycle ratio is 0.81 second, and the dead time is 0.93 seconds. Okay, about the observation, the CCDs took image at exactly the same time under the same conditions. All the simultaneous images were married in the pair to get integrated image. A total of 234 images were taken of 24 usable images were at the time of the occultation. So we have 24 images during the occultation, and we have some pictures after the occultation because of some calculation. It should be noted that some images have been deleted due to high noise or sudden atmospheric problems. You can see the mid time we calculated for this observation. Okay, the next step was a very important step, data reduction, because we haven't good position for Pluto during the occultation, just about 7 degrees above the reason. So it was very challenging and very hard observation, but the observer was they had a good experience. And before also they observed about many exoplanets, so they had very good experience for this observation. The raw images were aligned by AstroMate software, AIJ. It is very professional software, especially it's used for exoplanets. Deep Sky Striker software was used to mitigate each pair of images. The data reduction was performed for bias chart and flat field of each CCD image according to the standard method based on the AstroMate software. An important part is air mass. Air mass was calculated based on the observational location that influenced and improved the light curve for the entire length of the observation. Accordingly, we computed the air mass based on the AstroP package in Python. One of the other of the article wrote about this, and we use it. In order to obtain the pressure of the atmosphere, we feed the occultation light curve throughout the DO15 atmospheric model, which provided by Dias Oliveira et al. In 2015. So according to this model, we considered the surface radius of Pluto about 1,187. Three parameters are as the DO15 model to generate the temperature profile. Finally, we obtained the pressure of the atmosphere by using our ray tracing code based on the pressure at the reference radius of 1,215 kilometers and relative Pluto plus Charon flux as a reference value. So we wrote the ray tracing code in our team. It is very hard step. It's about I think 5 months. We trying to write this because there is not we couldn't find any other code about this, and we study and wrote many of read many papers and books about that. Okay, the next step, the quality of the fit shows like the chi-square per degree of the freedom. The figure shows the chi-square map as a function of the surface pressure and the distance of the closest approach of or the observation place to Pluto's shadow center. Closest approach of the Pluto's shadow center is about 605 kilometers. For us, about, I think. The chi-square value of the best fit is 10.23 with 19 degree of the freedom, 24 data points, and 12 free parameters, which indicate the satisfactory fit of chi-square DOF to 0.853 degree of freedom DOF. Okay. The best fitting parameters which achieved from or ray tracing code are listed in the table. You can see, and compared with other Pluto's atmospheric pressure value from 1988 to 2016, they were obtained based on the same Likert fitting model. As can be seen, for present occultation, the reference radius pressure is about 6.72 microbar, which corresponds to the surface pressure of 12.33 microbar. The observed change in the pressure values in the table can be explained by the LMD model. Okay, the figure shows the other atmospheric pressure obtained from 1988 to 1219 stellar occultation, and also our result in 2020. You can see it by the red dot. The result of this study is agreement with the predictions of 2015 study, and most other that the nitrogen is increasing yet. Okay, as I said, this article is under review in the journal yet. At the end of this presentation, these are the names of the other persons that you co-created in this project, and also the abstract of this article. You can see it here. Thank you so much.
Thank you, Poro, very much for your talk. I would just like to make one comment. It was proposed way back in the 1980s that as Pluto receded from the sun in its orbit at about the present time, we might observe a reduction in the presence of its atmosphere. And it was proposed that its atmosphere would mostly precipitate onto the surface of the planet and just form ices on the surface. In fact, it appears, and your study confirms what other studies have shown, that Pluto's atmosphere may be slowly increasing in density in contrast to the expectations in the 1980s. An explanation for that, in spite of the decrease in insolation, that is solar radiation, is that it's a seasonal effect. That is, Pluto, as it moves around its orbit, it's highly tipped. Its axis is tipped to its orbit very highly, and it could be having a seasonal effect on Sputnik Planitia, so that a greater amount of sublimation occurs from that particular area of the planet, and paradoxically then increases Pluto's atmospheric pressure.
Yes, if you say about the 2019 study, it was about a Japanese, I think, team. We think it is not agreement with other studies, and or study also agreement with the 2015 study. We think it's increasing, yes. If I understand your explanation.
Are there any questions of Attila at this time?
Okay. Okay, Roger.
John Briggs, Attila. John Briggs wants to know what type of that telescope, that the 24-inch telescope.
Mm-hmm.
Is that? I guess he would be interested in who made it, and or where it's from, etc. What type of telescope? I understand it's a Schmidt-Cassegrain. Is that correct?
Yes, it's Cassegrain, and I think it's Germany telescope. Unfortunately, during the observation, I was not in Iran for being there, but some of my friends was there and doing that.
Okay. Again, thank you very much.
Thank you. Thank you so much.
Our next